Hi, my name is Thirupathi. I am working as assistant professor in electrical department in Marri Laxman Reddy Institute of Technology and Management. Today we are going to discuss electrical machines 2 unit chapter 1. Chapter name is three-phase induction motors. So first we will discuss about the syllabus. The syllabus is construction details of squirrel cage induction motor and slip ring induction motor, and production of rotating magnetic field. So how the rotating magnetic field is going to be produced, so what are the conditions it required, mathematical proofs, etc., and the principle of operation. So here principle of operation in three-phase induction motor is, it is a self-started induction motor, and single-phase induction motor is a non-self-starting motor. So how the three-phase induction motor is going to be self-start, and why the single-phase induction motor is not a self-starting. So this thing will be discussed at the principle of operation of three-phase induction motor. And here we have a parameters. So rotor EMF, rotor current, rotor reactance, rotor power factor, okay, and the relation between the rotor input, rotor copper loss, and rotor output. So today in this section we will discuss about the construction details, that is squirrel cage and the slip ring induction motor. Okay, so here if you see, it is divided into two parts. One is stator part, another one is the rotor part. The stator part is a stationary part, it will be not rotate, and it contains a three-phase winding. And the rotor part is a rotating part, and it is connected to the mechanical load. So here this diagram shows here two parts. One is stator frame, this is the stator frame, and inside we have a stator core, and here we are seeing the winding which is distributed. Okay, so first we will discuss about the stator. So stator contains again two parts. One is stator frame, another one is the stator core. So this stator frame is made up of cast iron, and it protects the inner parts of the machine. And the stator frame is also give mechanical strength to the stator core, and it avoid the dust particle, moisture, etc. into the machine. If the dust particles or air is entered into the machine, the air gap between the rotor and the stator, there we have a flux, so it will get disturbed. So to avoid that, we should not make entered into the air or dust particles into the machine. So that function will be done by using of stator frame. And another one is the stator core. This stator core is laminated to reduce the eddy current losses, and this stator core is made up of silicon steel. So these, why we are using the material of silicon steel means to reduce the hysteresis losses, and by doing of the lamination to reduce the eddy current losses. And the stator core have a slots, and in this three-phase induction motor we will use the semi-opened slots, and these slots, in these slots we will keep the winding, and the stator core is help us to make a distributed winding, and it is also laminated of 0.4 to 0.5 mm thickness. Okay, so this is about the stator frame and the stator core. Now we will discuss about rotor. So rotor is two types. One is squirrel cage rotor, another one is the slip ring induction motor rotor. So here squirrel cage rotor, why it is called as a squirrel cage means, when we remove the core of the rotor, the remaining winding which is have a bars, it looks like a cage, which the squirrel will be live in the cage. That cage will appears like a squirrel cage. So due to that it is called as the squirrel cage. Okay, and here instead of using of the winding, we are using the copper bars or a copper rods, and aluminum also we can use. Okay, so due to the smooth, and these copper bars and aluminum bars are short circuited with the end rings, and that end rings are made up of hard drawn copper for mechanical withstand. And here instead of using of winding, we are using the bar. So using of the bar, the surface of the rotor is smooth, so due to that the air gap between the stator and the rotor will be less. So when the air gap is less, the magnetizing current also we can use less. Why? Because if air gap is more, we have to increase the magnetizing current to link the flux from the stator to rotor. So here air gap is less, so due to that the magnetizing current is less. So easily the flux can be linked from the stator to the rotor. So here we are using the bars. Okay. So here if you observe here, it is a real time pictures we have. So here these are the end rings, here they are the end rings, and in between the end rings we have a bars, and if the core is removed, the beside of the figure if you see, it will look like a cage. So this is called as a squirrel cage. Okay. And the next here due to the short circuit of the end rings, we are unable to insert the extra resistance. So when there is no extra resistance are present, the initial torque will be less. Why? Because we are using the copper material. So copper material have a less resistance. So there is no chance of adding of extra resistance. So the starting torque will be poor. Why? Because the starting torque is proportional to the resistance of the rotor. Okay. So to increase or to improve the starting torque, we have to increase the starting resistance. So to do that, we are making the length of the bars will be increased. So when we increase the length of the bars, the resistance will be increased. Okay, R is equal to rho L by A. So R is directly proportional to L. So when length increases, the resistance will be increases. So here we are making a skewing. So we are making the bar some inclined position with some angle of theta. So that inclination will make bar's length will be increased. So the resistance will be increased. So the starting torque also increases. Okay. So not only by doing and this process is called as skewing. And if we do the skewing, we have some advantages. So here first advantage is the magnetic hum. So that magnetic hum is nothing but the noise will be reduces. So by doing of this skewing, the noise of the motor will be less. And the second one is it is a smooth operation. So there will be not a magnetic locking. Okay, there will be not a magnetic locking. And another one is it increases the effective transformation ratio between stator and the rotor. So these are the some advantages of doing of skewing. Okay. So next we are going another some important points regarding the slip ring induction motor, that is here whatever the changes occur on the stator, the same changes will be done in the rotor automatically. For suppose on the stator I changed 2 poles into the 4 poles, then automatically the change will be done in the rotor. So the 2 poles will be automatically changes into the 4 pole system. So whatever the changes will do on the stator, there is no need of doing of manually on the rotor. Okay. So it will be automatically done process of the squirrel cage induction motor. And wherever we required a constant speed rotation applications, wherever we required for a rotation purpose, that is nothing but even though the load is increases, the speed should be not change a wide range. So there we can use these squirrel cage induction motors. Mostly 90% applications we are using the squirrel cage induction motors compared to the slip ring induction motors. Okay. And next one is slip ring induction motor. So slip ring induction motor, here we are not using any bars. Here on the rotor we will use the winding. So whatever the changes will be done on the stator, that should be changed manually on the rotor. Okay. It is not automatically induced. Okay. And here we have a chance is that this rotor winding is connected to the slip rings, and these slip rings can also be connected to external resistance to increase the starting torque. So in previously squirrel cage induction motor, we didn't have a chance of adding of extra resistance, but in slip ring induction motor we can add extra resistance from the slip rings. Okay. So by adding of the extra resistance, the starting torque will be improved. So wherever we required high starting torque, there we can use the slip ring induction motor. Example in the cranes. So here we have some points. So this construction of slip ring induction motor is exactly similar to the stator of the 3-phase induction motor. And the second one is here we can use star or delta connections according to our convenience. And the rotor construction is also laminated to reduce the eddy current losses. And here we are using the slip rings mounted on the shaft. So slip rings will be kept on the shaft. So from the slip rings we can connect external resistance. Okay. So this method is also these extra adding of extra resistance method is also used for speed control of the 3-phase induction motor. This is another advantage. So here the two advantages by slip ring induction motor is, the first one is we can add extra resistance. By adding of extra resistance, starting torque will be improved, and by adding of extra resistance we can control the speed of the 3-phase induction motor by varying by increasing the resistance and by decreasing the resistance. So this is the convenient we have by using of the slip ring induction motor. Okay. And these are the references we taken. From these references we taken the diagrams. Okay. Thank you.